I'd like to welcome you to our lecture tonight. I am Sue Scharf, Director of the Wellness Forum. I'd like to extend special thank yous to our sponsors for tonight's lecture, Grand Rapids Community College, particularly Chris Arnold and her staff, the Van Andel Research Institute, and the Wellness Forum. For those of you who aren't familiar with the Wellness Forum, we are an international organization, and our mission is to empower individuals to take control of their health through education. Education that is science-based and works and teachings on nutrition, exercise, and lifestyle changes and how that impacts our health, our longevity, and our quality of life also. We do a variety of workshops, classes, cooking demos. Our center is located on Forest Hill Avenue, and we also go out into the community and do seminars and customized programs. So if any of you are interested in more information on the Wellness Forum, we will have packets as you leave the auditorium. It is my distinct privilege to introduce Dr. Colin Campbell tonight. I had the opportunity to hear him speak about a year and a half ago in Ohio, and I was so impressed and really realized that we needed to hear this word here in Grand Rapids also. For over 40 years, Dr. Campbell has been devoting time and his energy to researching diet and disease. And his goal is to provide the truth in the research, which wasn't always the popular opinion. So he had quite an uphill battle at times. He is a retired professor emeritus of nutritional biochemistry of Cornell University. He's the senior science advisor for the American Institute for Cancer Research and the World Cancer Research Fund, and is considered an expert on the links between diet and cancer. His awards are many, but a few of them include a 1998 award from the American Institute for Cancer Research in recognition of a lifetime of accomplishments in scientific research. Also in 1998, he was named the top 25 food influentials by Self magazine. And in 2004, he received the Burton Coleman Scientific Award by the Natural Nutrition Food Association. He has testified before Congress on numerous health policy issues, and of course from that came lots of interviews and magazine articles, and he has authored over 300 research papers on nutrition and health. A year ago, his book came out, The China Study, which he co-authored with his son. It is focusing on one of the largest studies ever done on human and diet and disease. And he shared with me one of the reasons he wrote the book was to promote discussion. And I know that you will have lots of discussion after you hear him speak. And more importantly, he's married, 5 children, and several grandchildren. So he has quite a legacy to leave them. Please join me in giving a big Grand Rapids welcome to Dr. T. Colin Campbell.
Thank you, Sue, and thank you for coming. I think it's all for naught when we run into computer problems, isn't it? I remember the days when I just went into a classroom with a chalk and a blackboard. You remember that too? I'm inclined to want to go back to that, quite frankly, at times. I want to thank Sue and her group, the Wellness Forum, for having me here. It's a very nice opportunity, I think. It's my first time here being in Grand Rapids, as a matter of fact. I've been in a number of places in Michigan, but I was just thinking as I was walking across the street, it's the first time I've seen your wonderful city. And, of course, I'm looking forward to talking to you folks. I know that I think a lot of you are associated with the Wellness Forum. And I must tell you that Dr. Pam Popper, who I think is known to many of you, is a really dynamic lady in Columbus, Ohio, who started much of this organization and now is sort of taking it across the country. And I've been around the country quite a bit during the past year since the book came out, talking here and there. And there's one group of people that seem somehow to get in the audience from time to time, from California to New Hampshire to Dallas, Texas. I can't remember all. There's a group of people I know when they're there. It's the Wellness Forum people. They are an enthusiastic bunch, and I think they're very much on the right track as far as information is concerned. So it is indeed a pleasure for me to talk to a group that's sponsored by the forum. And I hope that that's not going to work. Oh, wait a minute. Sorry about this. Everything that went wrong could have gone wrong, almost. There we go. Oh, good. Okay. If we can get the lights down just a little bit. What I really want to talk to you about, of course, is about food, about health, about disease, about maintenance of health, prevention of disease. And the information that I want to share with you started with me, at least, formally, 50 years ago this August, when I went away to graduate school at Cornell University to do a doctorate in what turned out in those days to be animal nutrition. I actually went away to school, in graduate school at the time, to do a research project as part of my doctoral work, to figure out how to grow cows more efficiently so we could eat more of them and drink more of their milk. I had come from a dairy farm. I thought it was kind of neat that I could learn how to milk cows by hand when I was 5 years old. And little did I know that that was going to lock me into a childhood of work. But anyhow, that was the background I came from. A meat and potatoes kind of guy, drinking lots of milk, the whole 9 yards. And so I went away to school at Cornell to embark on this idea that the great old American diet was where it's at. And specifically, I did my work, in fact, trying to figure out ways with my professors, of course. It wasn't solely my own, but did my dissertation specifically on the role of animal protein, in creating health. I mean, somehow animal protein has become the awesome nutrient, the most sacred of all nutrients, as you might imagine. And whether you know it or not, or whether we know it or such talked about it, animal protein has almost been the bedrock nutrient for as long as we've thought about nutrition, at least in this country. And so I was enamored with the idea too, really pushing animal protein, creating opportunities for people to get more animal protein, more total protein, of course. And as time went along, I got caught up in learning something rather different from what, in fact, I had been taught, the way I was raised, the way I did my original research, and I'll tell you about that in a bit. But as time went along, and I want to kind of share the story with you, in a sense, as a personal research journey. I mean, I didn't know that much about college when I went away to school. My dad only had a couple of years of education, actually, and I was the first one to go to college in my family. And so for me, it was very exciting to get in science and do these kind of things. And of course, believing in the way that we had lived our lives and the way we ate food and all of that. And when I got into my research program with my students, in science, we like to focus our hypothesis, as they say, on a very specific question, and then do the experimental research very carefully and understand it as best we can, and sort of develop it that way. And what turned out, in fact, is although I started with a very specific idea, it just kind of blossomed. You ask a question, you get some answers, it raises more questions than you started with, and then you just sort of keep asking more questions. And this one singular little question, very well focused, and I'll mention in a moment, gradually will start going like this. And so today, I would argue that nutrition is a concept, and it's a practice, and as a science, really ought to be considered the premier biomedical science of the future. And I really mean that, because I've become impressed with what food can do insofar as its nutritional activity is concerned to maintain health and prevent disease. And that awareness, that enthusiasm that I now have for this idea of maintaining health, prevent disease, comes from, doing the research and going like this, and then getting a big, broad picture of the expanse of the idea. Because in science, we tend to focus on one little thing at a time, and we work in our tiny little holes and never see much of what's going on around. And I also have gotten my views, as I'll share with you a little bit later in the lecture, in part from having been quite deeply involved for more or less 20 consecutive years at one point, being on some expert panel someplace, usually with the National Academy of Science, helping to write and develop national and international policy on diet and health, the kind of stuff that we hear as a public, and being involved in that process. So I did see, in fact, how scientific information that we tend to create in the laboratory, in universities and things like that, how that information then gets translated into public information, to create things like the dietary guidelines and create various incentive recommendations. So that's sort of the background. That was the background. My projector is now gone. No, it'll come back on. It better, yes. I know that this is Kathy, please. Gosh, I'm getting here problems here. I don't know what's wrong here. Why did that come back? Is the technical? Is it back again? Okay, I'm going to have to be over on this side so I can punch that thing and look at it crossly when it's acting up. Okay, so let me just give you a little background. I'm going to share with you just a couple of ideas that you all know pretty well. I mean, you've heard this stuff. I call it some dots in the matrix, that we're concerned with in the present day. And I want to connect some of these dots because all these dots seem to be disconnected, but they are really connected. Let me just say this. This is this kind of problem we're living with today. A third of it, 2/3 of us are overweight, a quarter of us are considered obese, if you will. The youth, our young people, are especially vulnerable. And we're kind of an overweight society to a great extent compared to what it was, 2 or 3 or 4 decades ago. We rely on drugs as a means of health. As the data here shows, some 5 years ago, half of us take one prescription drug a week to maintain our health or to prevent disease. Probably it's more than that now. And 80% of us, 4 out of every 5, take some kind of medication. So we rely on drugs. And I'm going to have to, no, I can't get this here up. In any case, many people still want to rely on drugs as a means of health. I was telling an early audience today that there was an article in our local newspaper about 2 or 3 years ago, and of course I believe everything in our local newspaper, by the way. There was an article there that nonetheless it was telling us that there had been a survey recently done saying that something like 77% of us in our country believe that drugs is the key to good health. 77%, can you believe that? So I think it's really fair to say we are a drug culture. We're relying on it. Now that's the antithesis of food as a means to health. You see what I'm saying here? So we've gone down the road to think so much about drugs as a means of health. We'll eat whatever we want, we'll get sick, and somebody's going to fix us. I mean, that's the kind of story. And in reality, food, through its ability to provide good nutrition, can do that much better, if we just do it right. Early as well as, I would argue, late, instead of drugs. Okay, so a couple of other things here. Is there any possibility I could get this here adjusted enough to get, well, let's forget. I'll just tell you the story. The stuff down here you can't see, it's kind of a secret, so I'll just... So I'll just make it up as I go along. Anyhow, healthcare costs are really high, as you all know that. I mean, per capita U.S. medical care costs is the highest in the world. We're about 50% higher than the second next highest country. We got a real problem. And when our health system is evaluated against other countries, as has been done by the World Health Organization of the United Nations, for example, when we talk about quality of health care and using their criteria to decide that, we are 37th in the world in terms of quality of health care. We don't have the best system, not in terms of the delivery of good health. We really don't. And so we got problems. Why is it we spend so much money and get so little in return for it? And it's getting worse. It's getting worse. We have a real serious crisis And this crisis, incidentally, now, you hear it every day. What's driving the debate about health these days is its cost. Let's face it. I mean, costs are very serious. Companies are sending jobs overseas because they can't afford the health premiums for their employees, or they're cutting jobs. Schools, escalating budgets going like this, that in turn then demand, higher property taxes. Why? Because the health care costs within those budgets are escalating faster than anything else. And so we see it across the landscape, and it's so serious in some quarters that we keep hearing about the doomsday predictions that the whole system is going to fall apart. In any case, I say that given that there's something missing, here's what's missing, is nutrition. We really don't, as a population, understand what nutrition can do. We don't understand how valuable it can be. It's poorly understood. Research funding for nutrition really hardly exists. I've had a long experience working with the National Institutes of Health and the American Cancer Society and places like that, who actually, the National Institutes of Health funded almost all of our research, I should tell you, rather than the corporate sector. It was your taxpayer money, by the way. So I'm coming to tell you how we spent your money, in a sense. In any case, the research funding from NIH, which is the chief source of biomedical research in the United States, the research funding devoted to nutrition is only about 2 or 3% of the total budget. 2 or 3%. And most of that money is used in clinical trials to test the activity of so-called individual nutrients, nutrient supplements. I don't call that nutrition. That's not nutrition. That's not nutrition. Nutrient supplements is not nutrition. That's pharmacology. That's drug therapy. It's just given a little earlier in our lives. Nutrition is something different, as we'll end up talking about. And of course, doctors aren't trained either, nearly enough. And what's hiding is the idea that national policy that is developed, you hear about, either directly or indirectly or subliminally or whatever. National policy today is really getting seriously corrupted by the private sector. It really is. I've seen it firsthand. I can give you verse and chapter, names, places, and so forth to make that point. But national policy, tell us what we should eat, how much of this nutrient, how much of that, is really seriously corrupted by the private sector. Now, we'll get into that a little bit later on, and that's what, in fact, is a source of some of the confusion that exists. I really do need, who's the fellow? Is he in the audience here someplace? I wish I could, well, anyhow, stop complaining about it, I guess, and get on with the job. There's something, what's this? It's good. I don't know why it keeps doing that. You can't see this, so I'll do the best I can to try to illustrate it for you. My story, as I said, started, I want to get in now to share with you some of the evolution of the ideas that we got involved in our own research program, and I'm talking about all my students and colleagues and postdocs and people like that we worked with over the years. My story started out in the Philippines early in my career, and I was with my senior colleague. We went to the Philippines to set up some clinical centers around that country, a poor country, to try to help feed malnourished children. And when we think of malnourished children in the world, especially in poor countries, it's usually thought that malnourishment comes either from a lack of energy or calories, in which case they get a condition called marasmus, or it's a lack of protein, in which case then it's called kwashiorkor. You may have heard of those terms. And so when we went to the Philippines to set up these centers, and we ended up eventually setting up 111 centers around the Philippines, this is back in the 60s, my focus, in large measure, and my colleagues' focus, was making sure they got enough protein. They were not consuming near enough protein in their food, or high-protein food as we were. That was suited me because that's what I believed in, too. And it turned out that, rather in a happenstance way, I learned about the fact that there were young children, 4 years of age and younger, who were getting primary liver cancer and dying. I learned this from one of my colleagues who was a surgeon at the time. Primary liver cancer, that was really an odd observation, because primary liver cancer tends to occur only in middle to older age people. And here were children, 4 years, not a lot, but some, who were getting primary liver cancer and dying. And I just happened to, It was a curiosity because I had an interest in liver cancer. I had an interest in protein. And so I was just asking around. It turned out those children were coming from families who were feeding and eating, most like us. They were from the wealthier families. They were consuming protein at the levels we do, instead of the rest of the country. I mean, they were few in number, but that's what they were doing. They were, and so all of a sudden I said, wait a minute, this is crazy. We're going there to make sure they get more protein, this very sacred nutrient, and high protein foods. And in reality, the ones who are getting the kind of protein that we wanted to consume were getting liver cancer. Maybe it's just a crazy idea, but that's the way it was. And it was about that time, though, that some studies came out of India on experimental animals, experimental rats, in which case the researchers were curious about this condition of liver cancer. Rats get liver cancer, could get liver cancer like humans get liver cancer in a certain sort of way, an experimental way. And it was considered to be quite a problem, this liver cancer deal. And what they wanted to know was if they gave these animals more protein, maybe they could prevent liver cancer or attenuate it. And they were thinking, you know, the reason liver cancer is pretty common in those countries is because they don't get enough protein. And here I was seeing the opposite. So they fed these rats the regular levels of protein, which is 20% of calories. That's considered regular level in those days. And they fed another group 5%. And these animals all were headed to get liver cancer because they've been exposed to a potent chemical carcinogen that gives liver cancer. Okay? So this is going to see, expecting to get 20% of the ones getting 20% protein was going to, you know, get less liver cancer. It turned out it was the other way around. 100% of the animals that got the 20% protein, the regular levels of protein, all got liver cancer. The animals given the lower level did not. And when I first saw that, first off, I thought, wow, this is kind of similar to what I was seeing in the kids. The ones given the highest levels of protein got the liver cancer, and the ones that got the lower level did not. And so it was certainly a curious thing. And so we came back home, I came home, and we set up a program that was funded by the National Institutes of Health for many, many years, where we focused on just that question. Because I had an interest in those days, how cancer works, especially how nutrition and diet might work in the case of cancer, how it sort of forms and grows and so forth and so on. And so I wanted to take that observation and look into it a little more carefully. Two questions. The first question was, is that really true? We wanted to do the study first off. Is that really true? It's too odd. That's too strange. You know, the higher protein turning on cancer, this is a kind of strange thing. The second thing, and we tend to do this in science, is to ask questions like, you know, how does it work? In science, it's one thing to make an observation, but I'm sorry about this. It's one thing to make an observation about some relationship, but if we can figure out how it works, we gain confidence in what we're seeing. And so we studied two questions, as I said. First, does it work? Secondly, how does it work? So I'm just going to show you just a couple slides here. This represents, as I say, 19 years worth of formal funding from the National Institutes of Health and even more years with funding elsewhere. And so you can't see it here so well, but, okay, you can see that red dot, can you all? In the back, okay? In any case, along this axis here, this is the number of precancer lesions in these animals. And what we're doing here is along this axis here, this is sort of looking at the effect of protein on the early development of these lesions. It's over the first 12 weeks, actually, from here to here. So we're looking at the formation of early cancers in these animals as a function of them consuming protein, either 20% or 5%. So if we give them 20% protein, for example, like the Indian workers did, you see that dotted line? These lesions come more and more and more over the 12-week period. They grow and kind of develop, and they're often running to become, let's say, tumors. In contrast, if we go back and do this study again, the first 3 weeks, we give them 20% to come up to there, and then if we have another group, they're at 20%, we give them 5%, we turn it off. And then we turn around and give them 20%, turn it back on again. And I could show this in many ways. It turned out we could turn on and turn off cancer development in these animals just by adjusting the protein intake. And it was entirely consistent with what the Indian workers had done. That is, the 20% protein actually caused cancers to grow, and the 5% animals did not, and we could switch it around and do this. But one issue here was the fact this is early cancer lesions. And of course, one would want to know, well, that's okay. What about waiting to see all the tumors fully grown? To see, I mean, so the next slide here is that. Animals are fed for their lifetime, which is 2 years, about 100 weeks. And so fed either 5% or 20%. And the animals fed 20% for the full 2 years. There's the kind of tumor activity. 33-21 in case you can't see it. 5%, 248. That's a huge difference. That's almost like a 100-0 score. And we didn't need a statistician to tell us whether that was significant or not. So this was essentially really confirming once and for all we were seeing the same thing as the Indian workers had. The 20% good protein levels turned on cancer, the 5% did not. But here, this is what was interesting. The 5%, the ones given 5% protein considered not enough, should have been suffering, ill health, maybe not living. Those animals at the end of 2 years were alive and thrifty, no tumors. They had sleek hair coats. They were active around the cage, jumping around the cage. They were actually consuming more calories, a little more, and surviving and getting no tumors, having less protein. And we studied the question concerning, what does calories have to do with cancer and things like that in some detail. And so then the animals fed the 20%, they're all dead at 2 years. So I think we essentially confirmed in spades the idea that protein fed at 20%, the usual levels is generally recommended, at least under these conditions, it grew cancers, the lower level protein. Of all this nutrients, my gosh, I mean, this really sacred nutrient we all worry about, we get enough protein kind of thing. And I'll come back to that point later. And here this protein was having a dramatic effect on tumor development. Now, admittedly, this is rats. This is liver cancer. It's maybe one could argue a very narrowly focused study, which it was. Of course, it was an opportunity to learn, how it all works, and I'll come back to it later. Now, one word of caution in some ways. I said 20% and 5%. We did a so-called dose-response relationship. We fed 4% and 6%, 8%, 10%, 12%, 14, 16, on up the line. It turns out protein is important. Protein is an essential nutrient. We need a certain amount of protein. And in the case of these rats, for example, they need about the same amount of protein as we do. And up to 10%, which is the amount needed for growth, no tumors really were growing. But once that level was satisfied, once they're getting enough protein to satisfy their needs, and they went in excess, this is when the tumor started to grow. So in other words, consume things at levels what we need. Don't be consuming in excess if you want to take that story, to the next degree. So we, as I said, were concerned about comparing 20% up here versus 5% down here, and obviously seeing these giant differences. But that's the more definitive relationship, if you will. Now, here was the part where it started getting really provocative. It turns out, when we tested soy protein and wheat protein at the 20% level, which turns on cancer development, we tested soy and wheat, it didn't have that effect. This was unique for the protein we were using. And the protein we were using was, of all things, casein. Now, I think that you know what casein is. It represents 87% of the cow's milk protein. That's a mistake. Well, 87% of the protein of cow's milk. One of the most sacred of all kinds of nutrient situations we can possibly imagine. It certainly is the kind of nutrient, if you will, that I, from my background, personally and professionally, thought was the very best. And so the casein of the animals is what was, in fact, turning on the tumor development. The soy and wheat did not. And so all of a sudden was emerging here, at least looking at this level, here's a casein, an animal protein, and these two plant proteins going like that. The animal protein was turned on cancer development, the plant protein was not. And so it was a fairly significant effect. Now, I told you I had a second question to ask, in this whole line of research. One was to see if it really worked like the Indian said it did. The other was to ask this question, how does it work? Well, being a biochemist and kind of getting inside of cells and looking at enzymes and looking at all these kinds of things that go on, which we were wanting to do, it turned out every time we looked for an explanation of how it worked in a mechanistic way, we found an explanation. And this is just a list. And for most of you, you won't know what all this stuff is, but it was really a lot of research. And what we found was that when these animals are consuming 20% protein, in a sense, everything went to hell in a handbasket, in a biochemical sense inside of the cell. All these different reactions were sort of operating in tandem, in synergy, as a symphony, and creating this response. So this wasn't a happenstance thing. So I really became convinced, obviously, casein can grow cancers. No question about it. And I have to tell you, I could have said it then, I can say it today. I know a lot about how we decide which chemicals cause cancer and which don't. They're called carcinogens, as you may know. I know that program. We spend $500 million a year on doing those kind of studies to see which kind of chemicals cause cancer, which ones don't. I will tell you, on the basis of this work, and knowing that program, knowing the criteria, that the most relevant carcinogen we consume is casein, bar none. In a sense, at least, that the levels we are consuming are those levels where we might expect to see a response. Unlike, the testing of other chemicals, which are often tested at, orders of magnitude higher than we ever get exposed to. Now, that's a harsh statement. That is a really harsh statement. Very provocative, obviously. And if I had gone out and told the press that, 20, 25 years ago, I wouldn't be standing here today telling you the rest of the story, I think. And I wasn't inclined, really, to... Somehow I wasn't inclined to want to believe it. Because, let's face it, we in science, we think we're so objective, or we try to be so objective. We're human, and, we have to admit we come to the table with our own personal biases. We always do. And don't let anybody tell you that, science is so pure, and we do bring our baggage to the table. And it was trouble for me, to realize that what we were seeing here wasn't what I had thought, and it wasn't what my life was all about. And just to prove that point, here I am sitting here in this combine some number of years ago, obviously, being raised on a dairy farm and going out and, cutting grain for others and stuff like that. So, it was kind of a shock. What do I do with this information? What do you do with something like this? So here's what we did with it. Partly for the reason of realizing that when we looked for a mechanism, we found all kinds. Partly for that reason, it turned out, in my view, that the whole role of nutrition, as far as its effect on health is concerned, is a very comprehensive thing. It's a very dynamic thing. It involves more than one nutrient. It involves food. It involves all the chemicals in food. It involves them working together. You see, it's a more holistic kind of thing. And we shouldn't take things so much out of context, no matter how remarkable may be results like this. They're real. We did it very carefully. It got published in very best journals. We repeatedly kept getting public funding for this work. It was judged to be good research in a very competitive process. But yet, we end up with results that are pretty stark. And so we want to go beyond that question, look for something more. Here's how to expand our horizon a little bit. Maybe casein is representative of animal protein in general. And incidentally, my inference to that, without having all the results, is yes, it is. Animal protein can, in fact, in my view, is much more likely to turn on cancer development than is plant protein, just for starters. But again, that's a little bit narrow. I'm talking about just this nutrient and that nutrient. Keep that in mind just for a second. Because maybe it's just not that protein by itself. Maybe it's animal protein is representative of animal foods. Maybe that's what it is. Animal foods and plant foods have all kinds of nutrients in them. Maybe this is sort of just an indicator of plant foods and animal foods, possibly. We should think that, at least consider that possibility. Maybe it's too much animal foods and too little plant foods. See how this questioning horizon is sort of expanding? Because plant foods, you know, one could argue, at least in the time when this was being done, as being protective against cancer. Animal foods were sort of coming up as possibly being associated with cancer development. You can't see that. I will tell you what it is. That next one is, the question is, I talked pretty much about experimental animal research. The question is, what about humans? So does this apply to humans? So with these questions in mind, then we had a chance to go to China to do a big human study, and in addition to some other human studies. And, oh gosh, this is terrible. And so we went to China. We did a big study involving lots of humans, and we could expand our horizon. We could look at lots of different kinds of diseases, quite frankly. We could look at, you know, all kinds of nutrient situations. We could look at patterns. We could look to see how things played out one with the other, to see how it all might relate. And in particular, I was interested, is there something here about animal foods and plant foods that might pop up and be important? And before I get to that, I want to tell you about some work that existed at that time, that's been shown many times, accepted by virtually everyone, that was the basis for some of this views that we had as far as our so-called China study is concerned. This is a plot here, you can't see the axis, comparing dietary fat intake along the bottom here versus breast cancer rates. And this is a bunch of different countries. This was published by the late Professor Ken Carroll, University of Western Ontario. It's been shown many, many times by many people. And what it basically shows is that if you put all these countries like this, and here's the United States up here, pretty high in breast cancer, very high in fat intake. And so you look at this and you see, boy, really impressive relationship between fat intake and breast cancer. The higher the fat intake, the higher breast cancer rates. Well, this story actually became, over the years, somewhat controversial, much debated. It wasn't clear how much fat really had to do with it. This actually was probably a reflection of animal food intake. And without getting into the details, why I want to tell you that is basically a reflection of animal food intake. That's the higher the animal food intake, the higher the breast cancer rates. And I think you would have to agree, that's a pretty impressive relationship. It really is. The other point about this, and that's where this line here goes, down there, is that when people move from, let's say, one risk area, one disease risk area of the world to another, in this case from a low disease risk area like Japan, up here to the United States, as people move from one risk area to another risk area and they change their diet and lifestyle, they get the disease risk of the country to which they move as they change their diet and lifestyle practices. That's been shown probably 100 times in different ways. And so, and also, it infers something else. These studies have been done in people who didn't change their genes. They kept their genes the same. All they did was change their diet and lifestyle. And all of a sudden, when they change their diet and lifestyle conditions, they get the disease that goes with that diet and lifestyle condition. That's what happens. And so, as I said, it's been done many times. And now, we knew those two things. We knew that cancer, for example, a number of different cancers, heart disease, it varies a lot between different societies. We knew if you move from here to there, you might gain or lose, depending. You know, we knew that kind of thing. So with that in mind, then we had this chance to do some work in China. And just a word about the background of that. This is a map of China, as you can see, and that's very well pictured here. But it was in the early 1980s. A gentleman from China, the first senior scientist from China to come to our country when we started talking to each other, our two countries, Dr. Chen Zheng, had some distinction in China before he came here. He came to work with me at Cornell University, wanted to work in the area of diet and cancer. And while he was at my place at Cornell, we learned about the Chinese government just having completed a marvelous study of how much cancer existed in a total of 2,400 counties across all of China. It involved about 88%, I think, or something of their population. And so then they came out with these maps like this. I wish you could see it a little better, but there's color-coded, and basically what it showed is that for breast cancer, and in about a dozen other cancers, these cancers tend to be very common in some counties, and not so in other counties. Big range. I mean, you could have a county here with lots of cancer and a county really nearby with very little of that kind of cancer. I mean, big differences. And the data had been ascertained to be really quite good because there were teams sent there from the United Nations and elsewhere, and was concluded that their information was pretty reliable. In any case, we said, okay, I said to the doctor, let's go do a study. Let's go see why it is in those communities that get so much cancer or other diseases, turned out. Why so? So we got funding from the National Institutes of Health and from the Chinese government, and this was the first project between the United States and China, first joint project. And we organized a study to do just that. And before we go on that, let me mention here, this kind of thing here where we know that cancer exists in some places and not others, I mean, we could conclude cancer is a geographically localized disease. It's not a disease of genes. It's not. It depends on what we're doing, where we're living, and how we live in our lives, and what we decide to eat and so forth. Okay, and this is the map of a bunch of counties that we selected for the study around China, covered most of China. It was a total of 165 counties, carefully selected to give us, what we wanted to get. 130 villages per county, two villages per county, and 6,500 adults and their families. And actually, we did that study, and then we went there. And when I use this term "we," I'm using it a little bit liberally. It was my Chinese colleague, Dr. Chen in particular, who did all this work. I mean, I kind of sit back and, went there and visited every year and stuff like that. But the actual work was done by our Chinese colleagues. And they went and collected dietary information over a 3-day period. What that meant, they went in the homes of these families, measured exactly what they ate. Really exactly what they ate. And then we could calculate nutrient intakes. A questionnaire was administered, and they were asked all kinds of questions. Are you smoking something? How much have you been smoking? Where'd you get your water from? What kind of food are you consuming? All these. When did you start having children? How many children did you have? And we asked all kinds of questions that we thought might have something to do with the development of cancer. And then we also collected blood samples, urine samples, and food samples, took it back, and there's about 24 laboratories from around the world that joined us, and we analyzed all kinds of things. And that was an effort to try to get some idea of looking at things comprehensively, putting things together to see what we could see. And of course, I was interested in the question concerning animal food and plant food at that time. Here's just a brief, I don't want to get caught on too much in the details because my battery's going to run out pretty soon, for one thing. But in any case, in China, here's China and the United States, they were consuming a really low-fat diet, only about 14% of total energy on average in rural China. We're up here a lot. They consume 3 times as much fiber. Fiber is from plant material, as you know. Animal protein, basically, the concentration of animal protein in our diet compared to rural China is 10 times greater. We are carnivores. We're basically carnivores, just like wolves and everybody else, it seemed like to me, compared to China. China was not consuming very much meat, so they didn't have very much animal protein. Body mass index, cholesterol levels are very low in China compared to here. It was considered heresy at that time to be so low. Their high was near our low, and that in turn was associated with whether they're consuming animal or plant-based food. Body mass index and energy intake, I'll just mention it quickly. We saw no obesity in China. No obesity, really. This is what this means, body mass index. We're around 27 now, but that's around 20. I mean, it's a huge difference, by the way. And yet they were consuming more calories. Really crazy. How could they be consuming more calories, 20 to 30% more calories, and have less body weight? Well, that raised a whole new question that we explored in some detail. There's a reason for that. They're more physically active. But incidentally, the Chinese group here were the ones that were least active. They were the office worker types. Even office worker types in China are more active than we are because they go to work with their bicycles. So the reason that they consume more calories in part because they're exercising more and they're spending more energy. But there was another reason. When they consume low-fat plant-based diets, then he can consume more calories, and it gets burned off as body heat. We sort of know that, instead of being laid down as body fat. So that's one of the issues concerning plant-based diets, low-fat diets. Okay, I just listed here. I ended up, when I was going through the years, turning up one heresy after another. And there's just a couple. I mean, blood cholesterol levels below 150 are safe, even healthy. You know, it's been told in this country, you get down to 150 or below, you're in trouble. Not good health. We are discovering, in fact, that cholesterol levels below 150 are quite safe and healthier. And consuming more calories, have less body weight, as I already mentioned. That's another one. So we had, and I don't have the time to get into this, but I just want to say we explored this mammoth amount of information. For those of you technically inclined or know something about this, we had 100,000 correlations to look at. 8,000 to 9,000 statistically significant correlations. So we had a huge body of data. We knew the quality of the data. And one of the reasons we had such good quality data, I have to give acknowledgement to my good friend and colleague from the University of Oxford, Richard Peto, now knighted by the Queen and known as Sir Richard Peto, the world's most prominent, probably, biostatistician. So Richard was the one who worked with us, set us right, make sure we got the design right, and got all this good information. In any case, we got all this huge amount of information, sit back, looked at it in terms of its patterns, looked at it in terms of assembling and this and that. And here was the kind of conclusion that we could draw. For minimal disease risk, virtually all associations favor nutrient composition of a whole foods plant-based diet. Now, I didn't expect to see this, to be honest about it, because here in China, I mean, they're already most of them consuming plant-based foods as part of their diet. I mean, they're going from 100%, let's say, plant-based foods in some areas, down to about 80% in other areas. They're not putting very much animal food in their diet. And I didn't think that little bit of animal food would make much difference. But it turned out it was very provocative. Putting that amount of much animal food in the diet did, in fact, associate with increasing cholesterol levels, did associate with emerging heart disease, did associate with more cancer. And so by this time, I'd say, and of course, looking at a whole bunch of different, we had 12 different cancers, heart diseases, infectious diseases, all kinds of things to look at in this context. And so finally, I'm saying to myself, here we got the animal data. Here's, a lot of work done by others. Here's the China data. At this time, it's time to wake up, because it's really about a plant-based diet. It's about a plant-based diet. Make no mistake about it. And it's not also about a single nutrient, by the way, protein or anything else. The protein was kind of the flagship, sending us down that path, thinking about things. And so I had to come to terms with it. Well, at that point, I said, wait a minute. What about this diet on other kind of diseases? I was thinking, well, here's what came to mind. I have a great deal of respect for nature, and I have a respect for the way we evolved and things like this. We are who we are as we evolved over time. And if you stop to think about it, if we identified the best diet for preventing cancer, I would hope that nature didn't play a fool trick on us. That the diet that best prevented cancer might be the same diet to increase heart disease or increase we would have to choose our disease, wouldn't we? If we finally came to terms with what that was. I was inclined to believe that since this information on diet and cancer in particular and some other diseases, I was inclined to believe that it was consistent for all diseases, but we had to know that. You had to look at the literature. I'm just going to show you a couple of things here. We got involved eventually in surveying a large amount of the literature, especially for the book that we eventually did, my son Tom and I. And I'm just going to show you a couple of things, because it turned out that the information that we eventually started turning up and exploring is information, A, that has been around a long time in some cases and just ignored. Or it's information being produced these days and still being ignored. But it's information. It's important. Here's something about prostate cancer and dairy, of all things. Here's what a review at Harvard just recently said about 4 or 5 years ago. 12 of 14 case control studies, that's one kind of study, and 7 of 9 cohort studies have observed a positive association for some measure of dairy products in prostate cancer, one of the most consistent dietary products for prostate cancer in published literature. We sort of know how it works. How many of you now know that dairy actually promotes prostate cancer and is so strong? Some of you do. You probably heard that from the dairy industry, didn't you? Here's a relationship between milk consumption and breast cancer. It doesn't prove that milk consumption causes breast cancer, but I can tell you there's a lot of background information here that leads us down that path. The dairy, in a rather complex series of biochemical events, when all put together, tends to be associated with an increase in breast cancer. Probably causes breast cancer, for over a lifetime. Gosh, now I'm really paying a price here for this being below the screen, because I wanted to show you this. This is, I could fool around with it and get it changed, but I don't have enough time. I'm afraid my battery's going to run out, so I got to stick with what we have here. This is a schematic of what we learned in China, women in rural China compared to British women in this case, British women being like us, in terms of what causes it. Let me tell you this much. We have a number of studies showing that the earlier the age of menarche, you all know what that is. The earlier the age of menarche, the higher the risk of breast cancer. Average age of menarche in this country is around 11, 12 years, maybe even shorter these days. And the age of menarche is a function of the kind of diet, to a considerable extent, is the kind of diet one consumes. It's actually a function of the rate of growth. If we take our kids and push them as hard as we can with a really rich diet, rich protein, lots of animal foods, lots of fat, if we do that, they grow the fastest. And we always want our kids to grow so fast. That pushes early age of menarche. They mature faster. When menarche comes, at that point in a woman's, young girl's life, the estrogen levels in their blood sort of surge. And they remain pretty high, during the reproductive years. And then when menopause comes along, it plunges. You know that whole story. Average age of menarche in America and elsewhere for women is, as I said, 11, 12 years. In China, the average age was 17 years. And when there were counties as high as the average age of menarche was 19 years. And so here in the United States, you start 11, 12 years, estrogen levels go up, and it turns out the estrogen level, we measured all this, estrogen level is about 50% higher in Western women than it is in Chinese women. And the concentration of estrogen in the blood is related to breast cancer risk, because estrogen plays a role. You probably heard of that too. It turns out menopause comes later amongst American women, around 52 years on average. Rural China is around 48 years. So you put the whole scheme together, and it turns out the American woman is being exposed to a lot more estrogen over her lifetime than is the rural Chinese woman, and therefore getting a lot more breast cancer. And so all that in turn is related to the kind of food that we're feeding our kids. And I would suggest, quite frankly, with considerable confidence, that the same thing exists for men with respect to prostate cancer. So having this long reproductive life, and we get caught up in a lot of sex, I guess, or something. That's why we have this long life. But in any case, having a long life like this, high concentration of hormones, it does a lot of things to us we don't particularly care to have, because it turns on breast cancer, prostate cancer, uterine cancer, and things like that. Okay. Here's just a different kind of disease. See, what I'm going to do, I'm spreading the wand a bit here. This is basically osteoporosis. This is bone fracture rate. Published in 1992 at the Yale University School of Medicine, comparing across different countries the intake of animal protein, and down here with fracture rate. The higher the animal protein intake, the higher the fracture rate, as you can see here. Also, it turns out the higher the calcium intake, the higher the fracture rate. Yeah, I said it right. The higher the calcium intake, the higher the fracture rate. So where do we get our extra calcium and protein from? Dairy. So if I plot dairy down along here and look at osteoporosis, the higher the dairy food intake, the higher the osteoporosis rates. Again, something you've heard from the dairy industry, I'm sure. We know a lot about how that works, by the way. We really do. Dairy's got protein in it, animal protein. Other kinds of animal protein does this too. It gets in our body, creates sort of a metabolic acidosis kind of condition. Our body doesn't like that. It tries to neutralize it. It pulls the calcium out of our bones, sort of neutralizes it, and we excrete the calcium, damage our bones. So we're getting that story pretty straight. And I think there's a lot of other information too to support that idea. Here's my favorite study. How many of you have heard of Dr. Esselstyn? Fair number, but not too many. Dr. Esselstyn, very renowned surgeon, one of the top 100 doctors in the country. He was a heart surgeon, longtime surgeon at Cleveland Clinic, recently retired. He's since become a good friend of mine. A humble surgeon, a kind of an oxymoron in a sense, but he basically came from a very distinguished, famous medical family and decided to test the effect of diet on men, mostly, 1 woman and 17 men, to test the ability of diet to do something with heart disease patients. He had gotten to a point where he thought that surgery wasn't doing it. You know, relieving some pain, yeah, but in terms of actually curing disease, no. So what he did, he took these heart patients and put them on an all plant-based diet, low in fat. About the same as we were learning from the China study. And we didn't know each other at the time. He didn't get that from me. He got that on his own, but it just coincided with what we were discovering in the China study. And so here was his results, more or less. He put them on an 8% all plant, 8% fat, all plant-based diet. He put in some lovastatin, which incidentally helps cholesterol get down. He did that because being in the medical community, no matter his fame, he had to do that to be part of the system. You know, he couldn't go the whole dietary way. So anyhow, he learned later that it's an all plant-based diet that can do this just as well. These 18 patients, when they went to the study, had had 49 coronary events in the previous 8 years prior to the study. That's about 3 apiece. They were sick. A lot of their physicians had told them it's time to go home, wrap things up. You're in a very late stage. They were in a bad way. He puts them on this diet. 20 years later, they go from 49 coronary events to 0 over the next 20 years. I dare say, I don't think anybody can think of a study more dramatic and more provocative, and in many ways more exciting than that. I mean, he's using diet to cure heart disease. He organized a symposium in Arizona and got a bunch of us there to talk in 1991. And that was when the early results were coming out. And he was saying, first, he had the audacity to say, the first national conference of elimination of coronary heart disease. You know, using diet. Later, he put it on down at Epcot, had us down there. Michael Eisner was interested because he had a heart disease. And about 300 cardiologists showed up. So, you know, this has been exposed. But unfortunately, a lot of people want to deny that it even exists or they've ever heard of it. But he's able to cure. And he's still doing that since he retired. Taking people seriously ill with heart disease, angina, pains, this and that. Can't do anything with their drugs. Getting worse. And they see Esselstyn. The 6 people who are on the American Heart Association diet, no gain. They got worse. So much for the American Heart Association diet. It had to go, you know, the whole way. Now, I wish I could have had the time to tell you about the effect of this diet and all these different diseases. It's really amazing that a lot of this information is very, very old, just ignored. And some of it is now being supported robustly in many ways with good, hard biochemical and clinical information to support this. I mean, multiple sclerosis, I thought was a tough disease. Couldn't do much with it. In reality, diet has a major effect on that, as been shown by a very famous researcher at the University of Oregon Medical Center, Dr. Roy Swank, where he basically can take diet and almost stop that in its tracks. I've gone around the country over the last year or so, and I've had at least a half a dozen or, I don't know, 7 or 8, I guess, people who have been in the audience who have had multiple sclerosis and have learned already. Well, a couple of them didn't. They were hearing it for the first time. But they had learned already they could stop multiple sclerosis symptoms by going on this kind of diet. If you go on the website, look at the 3 major professional sites for multiple sclerosis professionals, you see nothing on there about diet. They don't talk about that. It's where they want to do drugs. And so here's my definition of nutrition. I know I skipped through a whole bunch of stuff here, and a lot of it may not be terribly convincing. There's a lot of more stuff that we can talk about. But here's my definition, as opposed to the current definition. The current definition is vitamin C does this, and vitamin D does that, and vitamin E, and fiber does this, and protein does. I mean, we always think in these really narrow sort of slits, you know, a little bit of bits and pieces of information, and we get so confused. We think about how much is there, how much is in the food. Who cares? You look at these labels. We have RDAs, all that kind of stuff. Think about this. Nutrition involves the integrated effects of countless food constituents. Who knows how many chemicals in food? 100,000 maybe? Million? Our bodies is a marvelous machine. We consume this stuff. It comes in, our body decides on how much it wants of each of these things and brings it into the pool of reactions. If I could tell you what goes on inside of the cell, and creates this marvelous sort of workings to create health if you're given the right food, to create illness if you don't. I mean, it's just quite clear. It involves infinitely complex mechanisms to produce comprehensive health. And, you can't see that, it's my favorite one, I'll read it. The nutritional effect is greater than the sum of its parts. It's like a symphony. When you go listen to a symphony, you don't go there, one person working on one instrument, banging away on one note. That's not a symphony. But that's the way we study nutrition. We might add another note or so, but we're not looking at the symphony. We're simply not looking at the symphony. The symphony is marvelous when you start thinking about the integration of all this stuff. That's when you learn why it is that Esselstyn had such great results, and why it is that some other physicians now in recent years are also showing that you can take diet and do marvelous things with it. Not through supplements, but through food. I'm talking about whole food, whole grains, whole vegetables, whole fruits. I'm not talking about plant parts like sugar and white flour and stuff like that. I'm talking about whole foods. Working together, sort of a very natural kind of setting. And don't add back a lot of salt, sugar, fat, and dairy, by the way. So why is this information so invisible? This is it. I want to just share a couple of ideas with you because I've been involved in national policy, as I said. And this is what I find really troubling. I get excited about the information we're working on. I know it's there, and some of my colleagues know it's there too. But to even come and talk about this for a lot of people in the current setting is dangerous. They could lose the opportunity of getting more funding to do the research. They could lose their reputation. They could be kicked out of school, in academic settings. I'm serious about that. Somebody could really stand up and sort of say anything. I'm just recently retired, so I'd say. So why is this information more, invisible? Here I want to tell you first, there's two bodies, two committees in this country that set national food policy. One's called the Food and Nutrition Board, FNB, of the Institute of Medicine. What they do, they tell us every 5 years since 1943 how much nutrients we should consume. They set the RDAs, recommended dietary allowances. They give us specific numbers. Then they create, what they're doing is they've taken all the scientific information in the last 5 years, put it all together, making a big report, hand it off to the second committee, the Dietary Guidelines Committee. And the Dietary Guidelines Committee, what they do is they turn around and make little pictures for us. Like the food pyramid. Maybe they make a square. Used to. So here's the first committee filtering all the scientific information, seeing what it says. Give it to the second committee. The second committee, incidentally, is run by the USDA, Department of Agriculture. They're setting policy on human health. I think they're more interested in the health of livestock than they are in us. But they're setting those policies. And then we all sort of wait, what's the next pyramid going to say? I mean, anyhow, go to the first committee, the latest report, 2002. This is what it said. First page of about a 900-page report. It says, the report recommends that to meet the body's daily nutritional needs while minimizing risk for chronic disease like heart disease and cancer, adults should consume 10 to 35% from protein. I thought that was a typo. Because, the recommendation for protein over the years, the so-called RDA, was a single number, 10% is enough. Now they're saying we can minimize risk of chronic disease and go all the way up to 35% protein. Dr. Atkins had a field day. So to put that in a little perspective, here's what that means. Here's the level that has always been recommended as enough. But of course, none of us believe that's enough. More is better. So what we do, we consume somewhere between 11 and 22% in this region here. And this is the region here where these diseases emerge. When we go from there to there, that's when cholesterol levels go up. That's when calcium gets spilled out into the urine. That's when cancers start to grow. As we go from here to, not just because of the protein, by the way. It's because we're consuming foods because of our great reverence for protein, like animal protein. So it's a result of all kinds of things besides just the protein. But in any case, this is what we do. There's our average intake. Now this august body tells us we can go to there, sanctioned by the Food Pyramid group, and we can minimize disease risk. That is ludicrous. That is absolutely nuts. No, I don't know hardly anyone. There's some people today, I guess, get up there, but almost nobody even gets there. They tell us to even get higher. So let me just explore this question a little bit further. I'll come back to the punchline in a minute. Part of the same sentence, I broke it down. Here it is on added sugars. It says the report recommends that added sugars, and here's what they mean by added sugars: candy, soft drinks, fruit drinks, pastries, and other sweets, should comprise no more than 25% of total calories. Sounds like, they're looking out for our interests. We shouldn't consume more than 25% of our calories as added sugars, right? Well, it turns out that what it also says, we can consume up to 25% and minimize disease risk. That's what the implication is. At that time, the United Nations was organizing through the WHO a committee looking after the same sort of thing. And it was chaired by a friend of mine, and so I've seen the correspondence on this, not because of him, but I know the story from other sources. It turns out that when the United States body was deciding this, and more or less completing, the word leaked out that they were going to set an upper cap of 25%. The United Nations Committee had decided just about that time, they were running a little bit behind, they were going to set a cap of 10%. They said 10% is all we can have. The sugar industry heard word of that, sent a letter to the United Nations Committee, and said the U.S. Commission just decided we can go up to 25%, added sugar was no harm and it's safe and all that. You better get it up to 25%, not 10%. If you don't, we have friends in Congress and the Department of Health. And if you don't, we're going to go to our congressional representatives to get the United States to withhold funding from that report. That's the kind of hardball we're talking about here. The industry steps in, brings that kind of pressure, tried to do it in the United Nations Committee. Fortunately, it was chaired by a fellow who ran a Welshman running a research institute for many years in Scotland. And Scots are pretty tough. And they didn't shake, they didn't tremble even. They stood their ground and it's set at 10%. But the U.S. thing now is sanctioned at 25%. And so my son and I were doing a book. It was actually my son's idea in the beginning, so he did the calculations. We said, well, now we got the word from on high of what the best diet should look like in terms of nutrient intakes. So we put together a diet that would meet these new guidelines, and here it is. It's got 18% protein, 31% fat. See, this is. I wish I could move it up. Breakfast, lunch. You can't see the dinner. The dinner, you can have 3 slices of pepperoni pizza, 1 16-ounce of soda, and 1 serving of Archway sugar cookies. Now that's what the government is telling us we can have in order to minimize disease risk. And you wonder why you're confused? Or people wonder why they're confused? We're going to go no place. We're going to go no place, with this kind of information. It's just impossible. And so then we ask ourselves, you go on and you look further in the report and see who funded it. I sit on these committees, and as far as I'm aware, all the money that was made available to us for doing our work came from the public taxpayer, not from industry. This most recent round, there's a good chunk of money coming in from industry. The Dannon Institute, for this case, that's the dairy industry group. Very powerful dairy industry group. They kind of have an interest to get the protein up there so they can justify recommending more dairy consumption. International Life Science Institute sounds really grandiose, doesn't it? That's the coalition of soft drink companies. Coca-Cola, Pepsi, things like that. They kind of have an interest in getting sugar intake up there, right? corporate donors fund a bunch of food and drug companies. It's almost like, here's a group of companies in here wanting to promote sickness so that the next two companies here can put out the drugs to make us well. And I didn't tell you the bottom one, the bottom two. There's one more down here called M&M Mars. You've probably heard of that. And the last one is academic charlatans. They didn't list academic charlatans. That's my... But that's where the rubber hits the road. That's where the problem is, I have to tell you. These committees these days are now being put together. These sort of expert panels are being put together by some person in academia with a so-called distinguished name who is a consultant with industry. They go to Washington. They play a role in choosing who the members of the committee are going to be. And I can tell you their interest is not in the interest of public health. Their interest is to make sure that, they're who's holding their right hand or left hand, is kept happy. And unfortunately, I would say I'd like to think 99%. That's my experience of all scientists are really very honorable, hard-working people, really doing the best they can to try to, under the circumstances. The system, unfortunately, it's the system. It's not the individuals. It's not the dishonesty of the individuals. It's the system within which we live, how funds get dispensed, how we get promotions in terms of being able to do things. It's the system that's at fault here, together with just a handful of these so-called charlatans. Some of my colleagues will go and do that kind of thing and set policy. And so much of the information that we get, is troubling and confusing and damaging because of the way policy is set. We've detailed this, as some of you may know, in this book that I just did with my son, Tom. Tom, by the way, did a degree, and some people wonder why he was involved. He was involved as a true co-author. I have to tell you, he graduated from Cornell University in theater and was an aspiring actor. In fact, he was in Chicago. He's doing very well and all that. He decided to come back and help me write. And he did that very well. He got very excited about it. Now he's going off to medical school, by the way. Giving up acting. Maybe he'll be an actor in medical school. I don't know. But anyhow, we detailed in the book a lot of these arguments, a lot more than I've told here. And I actually want to, and it's based on as much, firsthand evidence as best as I can recall it. Also based on my own personal experiences as much as possible. And I want to now write another book that's more provocative, because I'm not sure that this is really going to do the job. So thank you very much. Yeah.
Yeah, I'll hand you the mic. There you go.
Thank you. Thank you for your talk tonight. I wonder what your opinion is, the data that you've looked at data in the aggregate, and I'm curious for your thoughts on something that I've read about called metabolic typing, and the theory that perhaps some segments of the population would do, that different people would do better with different diets, so that perhaps some populations would do better with a higher protein or higher fat diet than others, or some people, maybe not even populations, but down to the individual, that their biochemistry may be different. I'm curious what your experience or comments would be on that.
And the first approximation, I like the concept of metabolic typing, by the way, because that suggests to me that in order to estimate risk of disease or state of health, we should look at profiles of all kinds of things working together. That's the way I think of metabolic typing. In that sense, I'm very much for it because it's a very comprehensive point of view. Unfortunately, there are people, though, that want to argue that by doing metabolic typing, we can actually specify who gets which kind of product or diet, essentially. There are obviously differences between all of us, but it's more a matter of degree. Some of us will benefit greatly by being really pure about consuming a plant-based diet. it's a matter of our life. You know, like people with heart disease and things like this. Other people, you know, can smoke until they're 5%. The other 95% can't. They get some kind of problem. So we don't know who we are at any point in time. And so that's part of the problem. And so there are, I mean, amongst all of us, some of us are going to benefit, I say, greatly. Some of us may be much less so. But here's the important part of it. If everyone consumed this kind of diet, which I say is ideal for virtually everyone, it means that some people are not going to gain a whole lot, maybe. They'll gain some. And a lot of people gain a lot. But no one's going to really get worse. That's the point. So the metabolic type of thing, unfortunately, from my perspective, has been designed by people who want to sell some products. You know, you got this product for this condition, this product for that condition, this product for, you know, and so it's going down that track, which I don't like, because I don't think that that's a kind of a good money-making proposition. But it doesn't make any sense, you know, biologically.
Other questions?
My question is on cholesterol. What level of cholesterol total cholesterol would you recommend as an optimal or ideal level for most people? Caldwell Esselstyn would say that you can heart attack proof yourself if you get below 150. And I have heard health experts who have recommended that the ideal level for total cholesterol is 225, based on the nurses' study and other studies that they have read. So what would you recommend?
Well, first off, I really agree with Esselstyn, incidentally, in the sense that you don't see heart disease once you get down to 150 or below. But I want to add a caveat to that, or at least a trailer onto it, namely that total cholesterol is only roughly estimating heart disease risk. We know some people who got fairly low levels, like 160, 170, have a heart attack. We know other people who have 250, 260 don't. So we get a lot of mix. So it's a crude estimate of heart disease risk. Let's admit that first. But, you know, if you do a population study, clearly higher cholesterol is on average higher heart disease risk. There's no question about that. It's just when you come to the level of the individual. When you come to the level of the individual, then total cholesterol is not enough to measure. You know, we should add some more things to it. We should look at the ratio of total cholesterol to HDL, for example, or, you know, LDL to HDL. We can add some other wrinkles to that, too. These days we can sort of estimate, we don't do it very often, but we can estimate what percentage of that cholesterol is oxidized and which is not. We can add some more wrinkles to that. You know, how much antioxidants you have in your blood. If you have high cholesterol levels and really a lot of antioxidants to compensate for that. See what I'm saying? And so we have to remember that cholesterol levels is an approximate. It's a pretty good indicator on population level, but it's only an approximate indicator of heart disease risk. So I don't get too caught up in, you know, being too exercised about, you know, the exact cholesterol levels some people have. It's just a good idea to try to get it down. It's clear that some people can't get their cholesterol levels down, even when they're doing everything just about right. It might be 180, 200, 220. For some folks, a small percentage of folks can't quite get it down, but are probably still experiencing good health. Because in those cases, they're doing everything right. Their bodies are loaded up with carotenes and all the antioxidants. So
You say don't get caught up in that single chemical.
yes. Right.
Look at the overall diet and lifestyle.
Right. The greatest sin in biological research, in my view, is the assumption that is very, you know, that reductionist science works. It doesn't. That's the stuff of the drug industry. I would say nature didn't design us that way. We got to think of things, you know, comprehensively. That's where the payoff is. But unfortunately, that doesn't make money. That's part of the problem.
Any other questions? Oh, one back here.
I was fascinated by your comments about the children in the Philippines.
Right.
Why do you think it is that the childhood cancer rate is probably significantly less in the U.S. or other westernized countries compared to that particular study when our children presumably consume a significantly more, especially animal protein from milk?
Right. Excellent question. I only told you part of the story. In the interest of time, actually this has been one of my chief areas of interest over the years, is liver cancer, how it works. It turns out there's another factor involved in the etiology of liver cancer, and it happens to be hepatitis B virus and hepatitis C virus. That is to say, chronic infection with HBV or HCV basically really elevates risk for anybody who has that chronic infection, right? And the cancer itself seems to involve this kind of step. It starts out first with a gene aberration caused by, let's say, a chemical, maybe in some instances, or by one of these hepatitis viruses going to crank it away and keep hitting that gene. It turns out that, and then from there on, it's a nutritional disease. From there on, it's a nutritional disease. It turns out that in some very good studies, and this is well accepted now, almost 100% of the people who get liver cancer have been or are chronically infected with HBV or HCV. And we included that part of our research too. I didn't show it here. But they're chronically infected. People who are not chronically infected are not at risk of liver cancer, are very, very low risk. And so the difference between China and here is that in China, the percent of the population who are chronically infected is around 12 to 13% of the people who are chronically infected. In this country, it's between 0.1 and 0.3. You know, they have about 40 times the concentration of people in their population who are at least predisposed to getting liver cancer. That's why. So they start out, you know, with a much higher concentration of people able to get the disease in the first place. Thank God they're not consuming too much protein. Because if in fact they consume the protein like we did, it would explode. In our country, we can get away with consuming more protein like this and not get liver cancer simply because, although liver cancer is rising here, we can get away with that because we don't have too many people who are chronically infected. See my point? And a lot of diseases work that way. You got this factor, and this factor, and this factor. Oftentimes it's a virus, maybe a chemical, but in the end result, at the end of the day, it's the kind of nutrition we're consuming that keeps all this stuff under control. That's why it is. We didn't know that, by the way, when we did the China study, because that hadn't yet come up at that time about this HBV, HCV thing. But it's since evolved.
We had one other question in here. There's a current opportunity, thanks to our government, for public school systems to define wellness policies within the school districts, and I was just wondering if you could comment on, if you were able to be on the draft committee of a wellness policy, what would you put in the policy?
Well, the first thing I would do is ask the government to take control of the school lunch program away from USDA. Yeah. That's the first thing. Because we are, in fact, feeding our kids subsidized foods. You know, that farmers have been compensated for, and we want to find ways to dump that off on children. That's the first and most important thing. The second thing, and sort of a corollary to that, I would not insist that every school system that offers a school lunch program also have to offer the dairy option. That's required as part of the federal policy. If the school is going to offer the school lunch program and have access to those commodities, they have to offer the dairy option. And at the local level, unfortunately, everybody believes, you know, teachers and others, we're really, I mean, if kids don't choose not to drink the milk, you know, the parents hear about it. And so at the local level, it becomes a really very aggressive kind of notion of making sure they drink their milk, you see. So those are two things. And the third thing, of course, I would offer a person's program that I happen to know, one of former students, Dr. Antonia Demas in Trumansburg, New York, who has now offered this to something like 300 schools around the country. She went as part of her doctoral program at Cornell and showed how she could go into these schools with little children and offer them basically a plant-based diet. And they learned. Little kids, kindergarten, third or fourth grade, they learn. They go home and they get caught up in it because the kids are allowed to get involved in cooking. It's a multicultural kind of thing. It's a very exciting thing. Dr. Nemes is fantastic with children. These children go home and tell their mothers. And the mothers better start eating that way too. So it goes. We can do a lot with the school lunch program, a lot. But I would suggest one thing to do, and any of you interested, contact Dr. Antonia Demas. She's terrific, absolutely terrific in her program.
On a note, I might mention the Wellness Forum is having a conference this August on children's nutrition and bringing in speakers from around the country. And she I believe she was at our previous conference. But so see us if you're interested in hearing more about how to do this. Any other questions? Oh, we got a couple more, and then.
Sure.
Yeah, I'm curious to know what you think about organic meat versus meats that have been, inundated with chemicals and hormones and steroids and things like that. What is that doing to us? If you ate organic meat, is that better than, or are the chemicals causing problems like all these diseases?
I wish we had the answer to that. It's certainly a good hypothesis, and I think on the basis of the information that I know, it would be better, if you're going to eat meat, to choose grass-fed beef and organic farmed animals. It's not that I have seen data where hormones and pesticides and so forth and so on are explicitly associated with the hazards of eating meat. It's not that. It's just that it sort of makes good common sense. Furthermore, organic grass-fed beef are not so laden with so much fat, like the grain-fed feedlot animals are. And so I think the kind of meat that we're mostly accustomed to, as feedlot animals, rich in fat, obviously laden with hormones and everything else that goes along with it. And so the question is, how much of this meat effect, if you will, is attributed to that, and how much is attributed just to the fact that it contains a lot of protein and, as an animal-based food. And part of the information that we can sort of glean from this story is to look at wild game. If we look at wild game and look at the nutrient composition of wild game, as has been done, it turns out the nutrient composition of wild game, obviously grass-fed, is quite different. It's quite different. And in fact, there is a tendency for that composition to indicate, less problems, than the grass-fed beef. So I just think that we have really good evidence to suggest it would be better. I don't know, though, taking that next step, whether it's, how much difficulty there is really associated with that. We don't have a chance to get that much kind of food, that kind of meat. It's obviously some. Oh, there must have been. I just don't know them. I haven't seen any particularly publicized. I'm inclined to think, though, that not to consume it, and primarily because even organic-fed animals, grassland-fed animals, they still don't have all the antioxidants that plants do. They don't have any of the dietary fiber material. That's so important. And they still have protein that tends to create a pro-oxidant kind of environment. So, I mean, I still think there's problems, really significant problems with that kind of food. But perhaps, let me guess, much less so than, it's probably not a very satisfactory answer, as best I can do.
Thank you. What was the meat like in China?
The meat in China primarily was pork and chicken. And in the home, I mean, it was like a family keeping a cow or a couple of chickens or something like that. And it was more a feast day kind of thing.
So that was closer to organic meat than
Yeah, I think so. As near as, in most cases, right?
Yes, I have a question about breast cancer in the geographic regions. I'm from the Marin County, which has one of the in California, which has one of the highest breast cancers rates in the country. Yet it's also one of the highest that eats organic, natural foods, and it's one of the least meat consuming. And so I'm wondering how that ties into that here.
I just actually lectured in Marin County not too long ago and was apprised of their views on that. Their views are rather similar to Nassau and Suffolk County in Long Island. If you're familiar with that story, kind of upscale kind of populations who claim that they have higher breast cancer rates. But quite frankly, if you look at the data, I'm more familiar with the two counties in Long Island than I am in Marin County in this case. But the increased breast cancer rates, much too much is made of it. It's like, 10, 20, 30% higher maybe. That's nothing compared to China, where we're talking about 500, 1,000% increase. So I think the differences that we see in cancer rates in different counties around this country are not enough to attribute to anything. They may be a statistical quirk, and they're relatively insignificant. So I mean, you tend to get in upscale counties for one thing. Upscale counties historically have been counties where, people tend to consume richer food. That's enough, right there possibly, to account for a 10 to 20 or 30% increase. So I don't make too much of those kind of claims.
Well, we'd like to thank you again so much for a great lecture. Let's give him a hand. Thank you.